Hello and welcome to today's webinar, Business Digital Transformation versus Mainframe Applications, a Practical Approach, brought to you by Software Diversified Services. My name is Casey Smith, and on behalf of Share Headquarters, I would like to thank you for joining us today. Share is pleased to continue our webcast programming with this informative and educational event. Please note that presentation slides, recording, and handouts will be available post-webcast at share.org. Today's presenter is Patrick Fournier, Virtel Solution Architect. Patrick has over 40 years of experience with the modernization of IBM mainframe applications. He is currently the Senior Solution Architect for the Virtel Web Suite, a comprehensive web enablement solution for IBM mainframe applications published by Sysprotect Communication and distributed in North America by Software Diversified Services. We encourage you to submit questions throughout the broadcast via the Q&A box on your webinar toolbar. These will be addressed at the end of the presentation. I would like to now turn the webinar over for a brief introduction from Software Diversified Services. Please go ahead, Lisa.
Thank you, Casey, and thank you all for joining us today. Don't forget about our handouts, and we enjoy answering all of your questions. It's important to begin with a brief overview of SDS. We have been in the software business for over 36 years, and our headquarters are located in Minneapolis, Minnesota. We have grown through in-house software development and acquisitions to a portfolio of over 25 SDS products and a global user base. We've been primarily devoted to the mainframe market, especially helping organizations with their cybersecurity and compliance needs. We are lucky to have such an amazing group of development, support, and sales professionals, all U.S.-based in Minnesota, Arizona, and on the East Coast, that are always willing to go the extra mile for a customer. We look to partner with international partners with subject matter expertise to provide technologies that will fit well with our portfolio and fill a need in the marketplace. Sysprotect is a perfect example of one of those partners. Our partnership has lasted nearly 5 years now. Sysprotect's main technology is Virtel, and it fits in nicely with our motto that dates back to the 80s, do more with less. We are delighted to have Patrick Fournier here to discuss a hot and trending topic, business digital transformation. He'll explore the necessity of undergoing a digital transformation for most businesses, along with some possible solutions, one of which is Virtel. And let's hear from Patrick now.
Thank you for your introduction, Lisa and Casey, and thank you to all attendees for your interest. We have lots of content to cover, so let's jump in. If, like me, you have been in the mainframe industry for the most part of your life, you may be wondering, why is everyone in the mainframe industry talking about digital transformation lately? Haven't mainframe been evolving for the past 40 years already? What is different this time around that gets everyone buzzing about digital transformation? Well, it started a few years back with the likes of Amazon, Uber, Lyft, and Airbnb. Those tech companies managed to fundamentally disrupt the industry by capturing major market shares within only a few years. In some cases, they even managed to put established industry leaders out of business. How did they do this? What is their recipe? What do they all have in common? First, those companies have been particularly receptive to recent market evolutions. For example, the pervasive availability of 4G LTE and other high-speed internet connections, the pervasive usage of smartphones and smartphone apps, the exploding mobile consumer market, geolocation and other new mobile technologies, the undertapped part-time workforce, the growing pool of young and web-savvy application developers, and the growing arsenal of web development languages, tools, and technologies. Industry disruptors have also focused obsessively on customer experience. They have reinvented the customer experience from scratch in their respective markets and are constantly adjusting their products and services to further improve their customers' experience. It only takes one ride with Uber or Lyft to realize how more convenient those ride services are compared to traditional taxi services. Industry disrupting solutions are resolutely web-centric. They rely on web user interfaces between customers and product or services, and they rely on web service interfaces between products and service delivery components as well. To increase their ability to adapt to changing marketplace and customer expectations, those industry disruptors have also elected to adhere to the Agile and DevOps methodologies rather than the traditional waterfall development methodology. Today, unless established businesses undergo a comprehensive digital transformation, they are bound to be overtaken by the next market disruptor. And this is a reason why everyone is buzzing about digital transformation. And IT is at the core of that transformation. Unfortunately, many industry-leading businesses rely on legacy mainframe applications for core transaction processing. It makes their digital transformation quite challenging because legacy mainframe applications do not have any of the required properties. They are not natively web-enabled. They rely on TN3270 rather than HTTP connections and on screen rather than web user interfaces. And their application components invoke each other through program calls rather than web services. They are written in COBOL and other legacy languages. Their code is old, complex, and poorly documented. Changes are risky, costly, and painfully slow. They follow the waterfall methodology, which is just the opposite of Agile and DevOps methodologies. The pool of mainframe application programmers is shrinking, many of them having reached retirement age, and the new generation hasn't been trained to work on mainframe application and is not interested to learn. Consequently, mainframe IT can hardly support day-to-day application maintenance. Changes are limited to what I would call survival maintenance. Functional improvements fall behind. I personally know of organizations that have a 2-year 50-project backlog for functional improvements. Under those conditions, how can mainframe IT participate in the business digital transformation? The different mainframe application modernization alternatives include redeveloping, replacing, front-ending, rehosting, and web enabling. Every single CIO and application manager has, at one point or another, considered redeveloping or replacing their mainframe applications. A number have tried. Those projects cost millions, last years, mobilize the bulk of the mainframe application development team, and do not deliver any benefits to the business until completion. The story is that 75% of those projects fail. Therefore, they are not a good approach to address pressing digital transformation needs. On the opposite end of the digital transformation spectrum is web enablement. It results in new web user and application interfaces, but it keeps the application's functionality and code unchanged, which makes it the low-cost, low-duration, and low-risk alternative. When it comes to digital transformation, web enablement is a safe, high-value, early return on investment alternative. Our Virtel Web Suite, which we will introduce throughout this presentation, is a comprehensive product line to web-enable IBM mainframe applications. Here is a practical web enablement plan for mainframe applications. The first step, which we refer to as web access, is to replace the TN3270 connections with end-to-end SSL encrypted HTTPS connections and the TN3270 emulation applets and plugins with a web-based solution. From there, it only takes a custom-developed cascading style sheet to give the screen interface the look of a modern GUI, without the smarts, obviously. The next step, which we refer to as web modernization, is to replace unassisted data entry with widget-assisted data entry. Widgets such as drop-down lists, checkboxes, graphical calendars are picked from one of the many JavaScript frameworks available. At that stage, the modernized interface can already be served to business partners, clients, or even consumers who think that they are driving a mobile web application when they are in fact driving a legacy mainframe application. Accessing the business products and services in self-service mode is a significant improvement in customer experience. The modernization of the user interface continues with the development of new workflows and new Ajax-based functionalities such as autosuggest, autocomplete, PDF generation, and emailing. This stage allows complete redesign and redevelopment of the customer experience. This is where mainframe IT can truly participate in the digital transformation of the business. Until that point, not a single line of code had to be changed in the legacy mainframe application, which made the transformation simple, fast, and safe. But optionally, the screen interface in the transaction programs may be replaced with a COM area interface, one program at a time. Because it now requires modifying legacy application code, this step is costlier and more time-consuming. It does not improve the transaction workflow or customer experience per se, except that removing the overhead of the transaction server's presentation layer improves the transaction's response time. Most organizations will also develop new web applications as part of the business's digital transformation to provide a new and improved customer experience. Those web applications still need to access the mainframe for core transaction processing, and they do that through interactive bidirectional connections in the form of one-off or reusable web, message, or email services that rely on HTML5, XML, JSON, JavaScript, RESTful, SOAP, and other such technologies. The end result is a hybrid transaction processing which involves components running on a mainframe and on distributed servers. Now, the full complement of web enablement solution has been deployed to support the business digital transformation and the improvement of customer experience it aims to deliver. This is what a hybrid mainframe web application looks like. For those of us who have worked with mainframe application for most of their lives, we are used to programs invoking each other via program calls. Programs running on different web servers invoke each other through web service calls. Programs participating in hybrid transaction processing invoke each other via program or web service calls, depending on the location of the calling and called program. This type of hybrid transaction processing environment should be the expected outcome of a business digital transformation when mainframe applications are retained. Let's look at the CIO's priority for the web enablement and the digital transformation it is a part of. The CIO wants to improve the customer experience by providing self-service access to products and services through mobile web interfaces. Wants to replace the main-centric IT infrastructure with a web-centric infrastructure, wants to abandon the waterfall application development methodology in favor of Agile and DevOps methodologies, wants to reduce the reliance on mainframe application developer and rely instead on the new generation of web developers, wants to rely on web rather than main application development tools and technologies, and of course wants to improve the security of IT assets given the wave of high-profile security breaches that have made the news in recent years. As we progress through our suggested web enablement steps, we will review how they meet the CIO's priorities. At this point, let's focus on the first part of our suggested web enablement plan, which we refer to as web access, and which consists in replacing the TN3270 connections with end-to-end HTTPS connections and the TN3270 emulation applets or plugins with browser-based 3270 terminal emulation. Virtel Web Access is the base configuration of our Virtel product line. With Virtel Web Access, the applets and plugins of traditional TN3270 emulators are replaced by the combination of plugin-free web browsers and 3270 terminal emulation web pages that Virtel serves to the client devices. It works instantly with any web browser running on any web-enabled device, including mobile devices, of course. So, how does Virtel work? Transaction programs interface with users via 3270 screens. Those screens are served to users via VTAM SNA connections. Virtel runs as a starter task on the ZOS or VSE system. It intercepts the VTAM SNA connections using a VTAM relay. Behind the VTAM relay is a communication protocol conversion engine which functions as an interface between VTAM SNA, the communication protocol of the mainframe, and TCP/IP, the communication protocol of the web. Behind the protocol conversion engine is an IP server, in the case of Virtel Web Access, an HTTPS server, which manages a TCP/IP connection with client devices. At runtimes, Virtel converts the 3270 screens into HTML5 JavaScript web pages, which look and behave as 3270 screens. Those pages can be rendered by any web browser running on any web-enabled device. This is the base configuration of Virtel. It is referred to as Virtel Web Access. Here is a sample of a terminal emulation web page generated by Virtel Web Access. Again, it looks and behaves as an actual 3270 screen. The toolbar at the top of the screen includes a virtual keyboard, a cut-copy-paste tool, a file transfer tool, a screenshot tool, a macro recording and replaying tool, access to the product documentation, a disconnect button, and a setting menus to customize the terminal emulation experience. One of the benefits of this browser-based architecture is simpler and fully centralized installation, administration, and support. There is nothing to install, administer, or support on the clients, no Java components, and no applets or plugins. The deployment couldn't be simpler. Just tell users to point their browsers to the installation-defined URL and port to reach the logon menu. The ZOS or ZVSC technical support team can do everything themselves. They no longer need to rely on the desktop support team. The support requirements and cost are drastically reduced, and the support team can focus on other digital transformation priorities. Another benefit of Virtel's browser-based architecture is that it works instantly with any platform, any operating system, and any web browser. There is nothing to do to support new client technologies. As long as a new device has a web browser that can render standard HTML5 JavaScript pages, Virtel can work with that device. Note that both user settings and user-developed macros can be stored centrally on the host, where they can be retrieved from any device used to access the 3270 applications. For example, an office workstation, home PC, tablet, hotel PC, and so on. This adds to Virtel's universal device compatibility. Virtel's simpler implementation and universal device compatibility are best illustrated by the story of one of our first customers, a global car manufacturer. In 2003, they decided to replace a costly private SNA network with internet connections. But with 400,000 users in 150 countries, deploying and supporting an applet-based solution was out of question. They needed a solution that would instantly support any client device used anywhere in the world by any one of their thousands of business partners, and that would not require installing, administering, or supporting client applets or plugins. This is why they choose Virtel Web Access. Another benefit of Virtel's browser-based architecture is that it is more secure than TN3270 emulators that rely on client applets or plugins. Virtel relies on end-to-end, that is, mainframe to client device, SSL encrypted HTTPS connections. The encryption is provided by IBM's AT-TLS or ICSF encryption services, which are always compliant with the latest FIPS and TLS levels. Today, FIPS 142 and TLS 1.2 or 1.3. Also, you can keep your VPN if you want to. A VPN is no longer needed to encrypt the data exchange on the connections. Also, there are no solution components residing on the client devices, where they could be compromised and used for unauthorized access to mainframe assets. No host data, no Java components, no client applets, and even no macros. With Virtel, even the macros can be stored on the mainframe to ensure that they are not compromised and used for unauthorized access to mainframe assets. And Virtel can integrate seamlessly with multiple factor authentication, single sign-on, proxy, and any other IP security solutions. VDI stands for Virtual Device Infrastructure. With VDI, the client devices are super light. The only software installed on those client devices are the operating system, web browser, and maybe a couple of extensions or applets, such as a remote desktop applet to support the client devices remotely. Let's say a Salesforce browser extension to access Salesforce if it is your CRM. The Citrix receiver to access the Citrix cloud. All applications are accessed through the web browser, and that includes mainframe applications, which Virtel serves to the client's device web browser via end-to-end SSL encrypted HTTPS connections. Another benefit of Virtel's thin client browser-based architecture is that it makes it easy to integrate seamlessly the 3270 screen interface with existing GUIs or web portals. We have done that for situations when the terminal emulation and GUI should auto-synchronize on a common file, for example, an account number. Change the account number in the screen interface and the GUI automatically positions itself on the new account. Change the account number in the GUI and the screen interface automatically positions itself on the new account. It makes toggling between the two interfaces much easier. Another benefit of Virtel Web Access over traditional applet-based terminal emulators is that it allows eliminating some mainframe products and their costs and support requirements. By default, Virtel serves to the users an application selection menu from which they can open multiple concurrent browser tabs or instances, each of them hosting a new concurrent session. This functions as a simple multi-session manager. And as stated earlier, Virtel relies on SSL encrypted HTTPS connections between mainframe and client device. Therefore, Virtel can coexist with a VPN, but with Virtel, customers no longer need a VPN for data encryptions. Deploying Virtel Web Access is very fast, typically a 2-hour installation, 2 to 8 hour configuration, and 1 to 3 months testing and deployment. It is all it takes to go from mainframe-centric to web-centric infrastructure. So, how does this transformation fare with the CIO's priorities? There is no development involved, therefore some of the CIO application development priorities don't apply. But this transformation puts in place a web-centric infrastructure that can be used in subsequent modernization and integration transformations, and it improves the security of access to mainframe assets from the web. At this point, let's focus on the second part of our suggested web enablement plan, which we refer to as web modernization, and which consists in replacing the screen user interface with a modern and user-friendly web user interface, or GUI. The same exact Virtel infrastructure used for 3270 terminal emulation, except with custom developed scenarios and templates, can convert a legacy screen interface into a modern and user-friendly GUI thanks to the insertion of widgets and new Ajax features. The development relies on two IDEs, Virtel Studio and Virtel Screen Redesigner. This configuration of Virtel is referred to as web modernization. This slide illustrates the type of transformation that takes place when Virtel replaces a screen interface with a modern and user-friendly web user interface. Green screen ergonomics are replaced with modern web page ergonomics. Function key navigation is replaced with tab navigation. Multiple screens can be consolidated into a single web page. Unassisted data entry is replaced with widget-assisted data entry. The first benefit of this user interface modernization is that users believe that they are accessing a modern web application when they are in fact accessing a legacy mainframe application. This is enough to eliminate the stigma typically associated with legacy applications. The same screens can be served at the same time to different users with different ergonomics depending on their device and preference. For example, desktop user can be served a web page designed for full-size monitors, while smartphone users are served a mobile accordion-style web page, and traditionalists are served a 3270 terminal emulation page. Given the right cascading style sheet, the mainframe application interface can be seamlessly integrated with the application interface of distributed applications to support new business processes. This further erases the gap between mainframe and web applications. Another benefit of this user interface modernization is data entry improvement. With widget-assisted data entry, users don't need to learn the authorized field values any longer. They just need to understand enough of the application's functionality to make proper plain English selections. Field data entry is controlled at the time of entry instead of once after all fields in the screen have been entered. The legacy application only gets valid application codes, and it eliminates at least 80% of data entry errors. Another benefit of this user interface modernization is the improved accessibility of the legacy mainframe application. All it takes to drive a transaction is to understand what you're trying to accomplish. Esoteric application codes are no longer visible. It helps attract younger staff members who otherwise would be turned off by the application screen interface. It can also help with temporary or seasonal staff who need less training. Furthermore, it makes it possible to extend selected transactions in self-service mode to business partners and even to clients and consumers. Besides reducing the internal staffing requirement and cost, it makes the delivery of products and services to clients and consumers more attractive, which helps grow revenue and market share and is completely in line with the ultimate objectives of the business digital transformation. Developing a GUI with Virtel Web Modernization is a cooperative effort between mainframe and web application developers. But the participation of mainframe application specialists is minimal. All they have to do is replace the screen fields with widgets using Virtel Screen Redesigner. While it requires understanding the authorized field values, it doesn't require understanding or coding HTML5 or JavaScript. Web application developers perform the bulk of the GUI development. With a cascading style sheet, they define the fonts, colors, and other style elements. They design the web page layout, oftentimes consolidating several screens into single web pages. They can add new Ajax features such as autosuggest, autocomplete, emailing, PDF generation, or retrieving and aggregating data from distributed servers into the GUI. While it requires understanding and coding website constructs such as CSS, HTML5, JavaScript, and Ajax, it doesn't require understanding the 3270 applications. The scripting is developed with Studio, while the layout and presentation are developed with Screen Redesigner. What makes the development and deployment of a Virtel-based GUI particularly fast and easy is the unique flexibility that Virtel provides. The first step consists in developing a default web page template which provides nothing more than a modernized look. The look is controlled via a cascading style sheet, oftentimes a mere copy of the corporate cascading style sheet. At this stage, no widgets or Ajax features are deployed. Despite the modern look, the ergonomics remain that of 3270 terminal emulation. This presentation ergonomics that will be used by default for screens will be used by default and for screens that have not yet been converted to widget-assisted data entry. The next step is to develop screen by screen the templates that will replace the entry of legacy application codes with widget-assisted data entry. Simple widgets such as drop-down lists, graphical calendars, checkboxes are picked from one of the many JavaScript frameworks, and they are used as front-end to the entry of 3270 screen field values. The development can be limited at first to the most highly used screens, which may be only a small fraction, say 10% of the total screen inventory. At this stage, all screens are rendered as web pages with a desired modern GUI look. Data entry on highly used screens is assisted by widgets. Data entry on lesser used screens remains the same as it was on the 3270 screens. The modernization of lesser used screens can then continue at any desired pace and go only as far as you want it to go. Maybe all screens will end up being modernized. Oftentimes, only some screens are modernized. It's your choice. The next optional development steps consist in adding new application features, features that do not exist in the legacy application using Ajax, which is asynchronous JavaScript and XML technology, or eliminating the screen interface in the underlying application and replacing it with a COM area interface. The progressive and agile development of a Virtel GUI is best illustrated with the story of one of our largest customers, the 10th largest bank in the world. They are larger than Bank of America or Wells Fargo. They have been using Virtel Web Modernization since 2005. They started by deploying Virtel Web Access for browser-based 3270 terminal emulation, but with a cascading style sheet to give it a look consistent with that of their corporate website and web portals, except, of course, without GUI smarts. Then they developed a basic GUI where they replaced unassisted screen data entry with the widget-assisted data entry. Again, drop-down list, graphical calendar, checkboxes, and so on. Then they leverage Ajax technology to add new user interface functionalities such as auto-suggest, autocomplete, PDF generation, email generation, access to server-hosted transaction and data, and more. Years later, having not used their screens for years, they replaced them with COM areas, one program at a time, to improve their response times where it mattered and reduce the CPU consumption of their CICS transactions. Until they started replacing the screens with COM areas in their programs, the CICS application remained unchanged by the GUI development. During the screen elimination phase, though, they were able to proceed one program at a time. So how does this transformation fare with the CIO's priority? It leverages the web-centric infrastructure deployed through the prior web access initiative and retains the security improvement deployed through the prior web access initiative. But in addition, it can improve the user experience to the point that transactions that couldn't be driven without training can be served in self-service mode to untrained temporary or new hired staff members, business partners, customers, or even consumers. It keeps the participation of mainframe application specialists to a minimum and relies instead mostly on web application developers. It can be developed in compliance with Agile and DevOps methodology and relies on web rather than mainframe modernization development tools and methodology. Such transformation is 100% in line with the objectives of the business digital transformation, and it provides fast deliverables and high return on investment. At this point, let's focus on the third part of our suggested web enablement plan, which we refer to as web integration, and which consists in integrating web and mainframe applications through interactive bidirectional web services. Before you select a web service development technology, you may want to clarify your requirements. What type of mainframe application will be exposed through web services? CICS, IMS, natural, batch? Some web service technologies are limited to CICS, while others can expose pretty much any type of mainframe application, including batch applications. Who will develop the services? Mainframe application developers, web application developers, hired contractors? In our experience, mainframe applications oftentimes entail complex transaction flows and error processing conditions, it is difficult for anyone else than mainframe application specialists to develop the web services. All web developers can do is state what they need to get out of the mainframe applications. How complex will the services be? Will the services have to deal with complex transaction flows and error processing conditions? Will they be incoming, outgoing, bidirectional? Will they involve interactive exchanges between mainframe and distributed applications? Web service IDEs may be easy to implement, but they can also be limited to simple requirements. What if the generator is not flexible enough to handle the requirements? Conversely, scripting languages can be powerful, but may be cumbersome to mainframe application developers. The ideal solutions combine an easy-to-use IDE with generated scripting code that can be manually modified when the requirements exceed the capacities of the generator. Next, well, will the services run on the mainframe or on a distributed server? It has a very significant impact on performance and scalability, as we're going to see later on. How to keep track of users accessing mainframe transaction and data. With 3270 terminal emulation, users log directly to the mainframe and their user IDs and activity can be tracked and audited. But with users connecting to the mainframe indirectly through a web application and web services, the mainframe loses track of who, as a person, was accessing or updating what. This probably should be a consideration. The same exact infrastructure used for 3270 terminal emulation, except with custom developed scenarios, can convert legacy application screens into web, message, or email services. The development is assisted with an IDE called Virtel Studio. This configuration of Virtel is referred to as Virtel Web Integration. All web services technologies can handle simple web services, but not many web service technologies can handle complex web services. Handling complex web services requires, among other things, a very flexible interface between the web server and the mainframe applications that the services must consume. Virtel provides this kind of flexibility. It is therefore able to handle not just the simple web services that all other solutions can also handle, but complex web services that few other solutions can handle. Virtel can interface with transaction programs of any kind, CICS, IMS, via VTAM SNA, EXCI, which is a IBM cross-memory exchange facility, VXCI, a faster monodirectional sysprotect proprietary cross-memory exchange facility, and TCP/IP. Virtel can also interface with non-visual batch-type programs via Virtel scenarios, calling VirSV a Virtel proprietary multitasking subsystem. Through VirSV, Virtel can submit non-visual programs for execution on either CPU or zip if they qualify for zip processing. The bottom line is that the interface between Virtel and mainframe programs is extremely flexible, which is what you need to address complex web service requirements. As we already discussed, Virtel runs on the mainframe as a starter task, next to the core applications and data it serves to the web. This is not the case of all web services solutions, many of which run on a middle-tier server, and it can become a real scalability and performance issue. Take the example of a custom truck engineering company that relied on an IMS application to manage its bills of material. Bills of material for custom 18-wheelers are huge documents. It used to take 50 IMS screens, and they were packed IMS screens, to view a complete bill of material. Then the engineering department has to have the bills of material served to their engineering workstations in one piece in either Excel or web page format. They tried first doing that with a server-based solution, but they ended up with 30 to 60 second response times. This was because going through 50 screens to reconstruct a bill of material was done over internet connections. It also created a scalability issue with the connections broadband being eaten away by the reconstruction of bills of material. Because it runs on the host, Virtel was able to reconstruct the bills of material locally on the host through memory exchanges rather than network exchanges, and to serve the reconstructed bills of material to the engineering workstations with a subsequent response time and without saturating the network. With Virtel, all web services are initially developed with Studio. It's an Eclipse IDE which automates the capture of screen flows, the XML COBOL data conversion, and the generation of web service scenarios which are coded in a dedicated scripting language. Studio also includes a web service testing facility. In most cases, manual modification of the generated scenario is not needed. But in case Studio cannot fully address complex web service scripting requirements, the developer can easily access the scripting code in the generated scenario for manual addition and changes. Modifying Virtel scenarios is relatively simple because the Virtel scripting language contains dedicated screen processing and conditional processing commands. For mainframe application specialists, this purposely designed scripting language is easier to learn and use than JavaScript. Of course, it is not a reusable skill like JavaScript, but a mainframe application developer will probably not reuse JavaScript skills anyway. Another instance when manually changing a web service scenario is useful is maintenance. Oftentimes, maintenance consists in implementing a small change. Manually modifying a few lines in the web service script is faster than deploying the IDE to regenerate the entire script. One of the issues when accessing mainframe transaction and data through web services is accountability. In other words, tracking what users as a person has accessed what mainframe resources and when. With 3270 terminal emulation, users log directly onto the mainframe. Their user IDs and activity can be tracked and audited. But with users connecting to the mainframe indirectly through a web application or web service, the mainframe loses track of who accessed or updated what. This type of authentication, authorization, and tracking is typically handled through SSO, MFA, LDAP, PIV, SAML, and other such facilities. Virtel does not directly participate in this tracking, but it integrates seamlessly with those facilities. It typically takes 2 to 4 hours to develop and test a new web service using Virtel Studio. Complex web services that require manual coding typically take 1 to 3 days depending on complexity. This includes testing, which can be done through a dedicated Virtel Studio facility. None of those development and testing require modifying the legacy application code because they leverage a screen user interface. And this is what makes the implementation so fast and so agile. But replacing the screen interface with a camera interface bypasses the overhead of the transaction server's presentation layer, which improves the performance while reducing the footprint. It requires modifying the application legacy code, and this is not the most agile approach to develop a new web service. Most of our customers start from the screen interface and replace it with a Camera interface later if they really need to improve the web service performance. A sample of our customer stories illustrates how different web services can be. Customers have used Virtel to integrate a WebSphere portal with a CICS application, call an outgoing SOAP web service from a CICS application, create an interactive bidirectional XML connection between batch and mainframe applications, integrate a CICS application with a PHP server, and even replace outdated SNA connection and 3745 controllers with a TCP/IP connection with a custom protocol. And that's only a short sample of our customer stories. So, how does this transformation fare with the CIO's priorities? First, it leverages the web-centric infrastructure deployed through the prior web access initiatives and retains the security improvement deployed through that prior web access initiatives. But in addition, by enabling web applications to securely access the mainframe assets and assuming those web applications are developed in accordance with the CIO's priority, it indirectly participates in improving the customer experience, adhering to the Agile and DevOps application development methodologies, keeping the participation of mainframe application specialists to a minimum, and relying instead on web application developers, and relying on web rather than mainframe application development tools and technologies. And this concludes my presentation. I want to once again thank SDS and Share for sponsoring this event and all attendees for their interest and time. So now, Lisa, back to you for questions.
Okay, thanks, Patrick. Let's answer some of your questions now. Just a reminder, we will email all of the questions and answers to the attendees shortly. So here's our first question for you, Patrick. It seems that Virtel works as a screen scraper. What happens when the screens change?
From a technical point of view, Virtel doesn't work as a screen scraper. It runs on the host and processes 3270 data flows directly off vSAN, whereas screen scrapers run on distributed devices and process reconstituted 3270 screens on the distributed devices. But in the end, you are right that if a host application screen changes, then the Virtel GUI or web service that processes the screen may have to be changed accordingly, a little bit like with a screen scraper. I'm not sure why screen changes are seen as more of an issue than program COM area changes. If the COM area changes in a coding program, then the COM area in the code program must be changed accordingly, right? So it is the same exact issue as screen changes. With screen scrapers, there was a definite disconnect between the mainframe application team and the screen scraper application support team when it came to screen changes. But this disconnect can be avoided with Virtel because the components of a Virtel-based solution are stored on the mainframe and can be placed under control of the change control system. Another point to take into consideration is that changes to application screens are less and less frequent with time, as legacy mainframe applications are stabilized, at least in their user interface. And some screen interfaces are also being replaced by web portals of all sorts. Finally, remember that using the screen interface is only the starting point for Virtel. You can at any time replace the screen interface with a COM area interface without impacting the product that Virtel serves to distributed users. Now, going from screen to COM area interface requires changing the legacy application code, and that takes a time and effort that may not be compatible with pressing digital transformation needs. But with Virtel, you can get your deliverable, whether it is a web user interface or a web service, really fast and cost efficiently by interfacing with legacy screen data flows. And then you can also bypass the screen interface if you have time and resource to modify your legacy application code. It's your choice. Back to you.
Okay, next question. Can specific LUs be used with Virtel?
Yes, you can assign specific LUs to a user base on IP address, workstation name, or user ID via specification of Virtel rules.
Great. Can I access my session manager with Virtel?
Yes, you can tailor the installation so that users access the session manager, for example, TPX, when they log on. But we found that in many cases, the session manager was no longer needed because Virtel can replace it by allowing you to simply open new sessions using multiple tabs in the web browser, allowing you to eliminate the session manager and save more money. Virtel can also be configured to serve customized session lists based on Virtel-initiated SAF calls.
Okay, next question. Does Virtel work with the host security product, and do you support SSO and multi-factor authentication?
Virtel will work seamlessly with any ZOS or VSC security product, RICF, BeamAlert, and so on, and can interface with any SSO or MFA products such as Okta, for example, on the client side. You can also implement HTTPS access and SSL encryption with Virtel by using IBM's ATTLS or ICSF.
Okay, next question. What is your licensing model?
We have both subscription and purchase licensing models. We use a tier pricing model based on user counts. Enterprise licensing with unlimited user count is also available. Significant discounts are offered to customers that license more than one Virtel product. For example, Virtel Web Access for 3270 terminal emulation plus Virtel Web Modernization for user interface modernization, or even the full Virtel Web Suite including access, modernization, and integration. For details, you should actually contact Laurie Cadle at SDS.
Okay, next question. Does Virtel Web Access support macros?
Yes, and with more flexibility than traditional 3270 terminal emulation products. User-defined macros can be stored either on the client device or centrally on the host, where they can be inventoried, audited for potential security exposure, and shared between users rather than duplicated by each user.
Thank you. Another question. Who installs, administers, and supports Virtel Web Access?
So the ZOS or ZVSC technical support team installs, administers, and supports Virtel Web Access or any other configuration of Virtel. The security team participates in the MFA, LDAP, etc. integration if applicable. Contrarily to client-based and three-tier web-based solutions, the distributed systems, that is a server and desktop support team, is not involved because there is nothing to install, administer, or support on middle-tier servers and desktops.
Thanks, Patrick. That's all the time we have for questions now. Back to you, Casey.
And that concludes today's webcast. We'd like to thank everyone, especially Patrick Fournier and the Software Diversified Services team for attending the event today. This feature will soon be available on the SHARE website at share.org. There is a survey after this webinar for you to complete, and we thank you in advance for your feedback. Thank you again for attending today's webinar, and have a great day.